Hey educators, do you ever wish that your students were more excited about learning math? That they were fluent with mathematical calculation, but just as comfortable with mathematical concepts and reasoning? If so, you're going to want to watch this video. I'll show you how you can use number proofs in a classroom, for homeschooling, or for online learning. It's a simple but effective activity that you can use again and again for a whole range of mathematical standards. So if your students aren't as excited about math as you think they should be, or if they're having a hard time with fluency or deep understanding, it could be that they're spending a lot of time doing the typical math problems that you find in a textbook or workbook. Those are questions like these that simply involve calculation. They don't necessarily require deep reasoning. And when students complete page after page of these exercises, it can feel really tedious. Not to mention, the type of math required for this is not always relevant to the real world. Like mathematicians in the real world are doing higher order math that involves flexible thinking, proving ideas. When we use math in the real world, whether it's to calculate groceries or find the area of a room, those are math applications that we don't really learn by doing these either. Now, these are some of the challenges that I was finding with my own students. When I was teaching 5th grade math, I had some students who came in and they were amazing calculators. You could give them a problem like this and they would have it in no time. Now the flip side of this is that there were a number of students in the class who were not very good with calculation, right? They didn't identify as mathematicians. They just figured, oh, I'm not a math person. So I wanted to find a way that I could challenge my high achievers to go deeper and a way to support my struggling learners to develop that fluency that they needed. And that's where I came up with the idea of number proofs. In this short video, I'll show you everything you need to start using number proofs with your students. First, we'll go over the benefits of teaching with number proofs. Then we'll work through some examples so you can see how a number proof works. I'll show you how to design a number proof lesson. And finally, I'll show you where to go to get more information and resources for teaching with number proofs. Number proofs take the way we usually ask questions in math and flip it around entirely. So instead of asking students, what is 4 minus 0.3? We might say 4 minus 0.3 is 3.7. And then the students have to prove it. Or we might say 4 minus 0.3 is 1, and they have to prove that that's false. In this video, we'll focus on closed number proofs where there are no variables, so every proof is either true or false. In our next video, we'll look at open number proofs that have variables, and students will have to prove whether it's always true, sometimes true, or never true. If you're interested in open number proofs, check out our channel and make sure you subscribe so you see that video. There are 3 main benefits that your students are going to get from doing number proofs. The first is just fun. Number proofs are a lot more fun than doing pages of exercises. You're going to find that your students are enjoying math more. The other is conceptual understanding. Instead of just repeating procedures and kind of being human calculators, your students are actually going to understand why math concepts, base 10 understanding, why negatives work the way they are, why multiplication and division are opposites, which is really powerful. And finally, the third benefit is differentiation. Number proofs are what's called a low floor, high ceiling task, meaning that any student can have access to this activity, and even your top students are still going to be challenged by it. There are also benefits for teachers, the first being time. Number proofs are what I call a recyclable activity. You learn this lesson model, and then you can use it again and again to address different content, which leads into our second benefit, which is they're standards-based. You can write any number sentences that you want to address your standards, and by proving them, your students are getting that content covered even without having to teach it directly or using the textbook. And the third benefit for teachers is it's a great way to promote collaboration and discussion. I know this can be a big challenge in the classroom. We want students to have mathematical discussions, but sometimes there's not really much of interest for them to talk about. Number proofs will give them plenty to talk about and create opportunities for them to work together. So let's work through a couple examples of number proofs so that you'll see how to use them with your students. There's really two parts to a number proof. One is proving by calculation, and the other is proving by reasoning. So we're going to start with a number sentence, a mathematical statement, whether it's an equation or an inequality. We're going to do these two methods of proving, and then we're going to determine whether that number sentence is true or false. So let's start with one of my favorite types of number sentences. In this one, we're looking at 3 times 8 on our left side, and we're going to see, is this equal to the quantity 3 times 2 plus the quantity 3 times 6. So first, I'm going to prove it with calculation. First step is to simplify on the left side. Then I'm going to simplify inside the parentheses on the right side. Next, I'll go one more step down and fully simplify the right side. So once I've come to an obviously true statement, I have determined that I've proved this number sentence true. Notice I didn't break the equation apart, right? Sometimes you'll see students will make it 3 times 8 equals 24 and then underneath make a separate equation. We want to discourage that. We want to keep intact the idea of equality as balance. Once they break it apart, sometimes it can get confusing for now what do I do? How do I put this back together? Keeping both sides balanced is an important aspect of algebraic understanding. You'll also notice I didn't use more than one equal sign on one line. Again, we're teaching left and right are balanced. Whatever I do to the left side, I do to the right side. So here, I've now proven that this number sentence is true using calculation. My next step is to prove it through reasoning. Now, what we don't want to do is just repeat the calculation. So if students say, the reason this is true is because the left is equal to 24 and the right is equal to 24. No, we're just putting our calculation into words. What we need to do is demonstrate an understanding of this problem and generalize it. 3 groups of 8 is the same as 3 groups of 2 plus 3 groups of 6, right? Because 6 plus 2 is 8. This is kind of a variation on the distributive property. So students might just say distributive property. Now, for some students, writing out a mathematical reason is going to be really challenging. So for their reasoning, I also allow them to draw a picture. So here you can see I've created an array, right? And we have 3 rows going down to show our 3 groups. Going across, I have 2 plus 6, and I can see that that's the same as 8. So here is my 3 groups of 2, 3 groups of 6, and that is the same as 3 groups of 8. I don't want to go too much into visual models because that's not the purpose of this video, but they can be a really effective way to show mathematical understanding. There are a number of videos in our channel on visual models, including arrays, number lines, area models, and so forth. So if you want more on visual models, check that out. So let's look at another example that shows how you can use number proofs with a middle school setting. Here we have negative numbers. We're multiplying -3 times -10, and we're demonstrating one that the students would find false, right? This is a common error that students make, that -3 times -10, they don't change the sign and they end up with -30. So let's show how we can prove that with calculation first. Now, if I know that -3 times -10 equals +30, I can just simplify that in one step and say 30 is not equal to -30 and be done with it. But and if our students do that, that's fine. But I'd like to show a little bit more some of the algebraic reasoning, so I'm going to take a few more steps to do this. First, I'm going to separate out my negatives from my whole numbers. Then I'm going to use commutative property and move my negatives out to the front. I've also used the associative property to add in some grouping symbols. And now at this point, you need to know that -1 times -1 is +1, so that could be the teachable moment. This is kind of the principle, if you will, of how we go from multiplying 2 negatives to get to a positive. So now I've simplified my -1s to +1. I've simplified inside this parentheses to get 30. On the right side, I just bring down my -30, and I end up with 30 equals -30, which is an obviously false statement. So I draw a line through my equal sign to show that this is not true, and I've now proven this number sentence false through calculation. So now the challenging part is to prove this through reasoning. Now, one way to do this is just by using the rule, right? So if a student says, well, a negative times a negative is always a positive, sure, that's a reason. But I would love to go a little deeper, particularly when I'm explaining to them after the activity. I can talk about opposites, right? If a negative is the opposite, well, then the opposite of 3, and here we have the opposite of 10, well, 10 groups of -3 would be -30, but the opposite of 10 groups of -3 would be +30. We can also demonstrate this with a visual model, and for this one, I would choose a number line. So on my number line, the left of the number line are my negatives, the right of the number line are positives, and each hash mark is a group of 10. So in order to prove this false, I'm going to start by going in hops of -10 3 times. So my 3 hops of -10 gets me to -30. But what we were looking for was -3, or the opposite of 3 hops of -10. In that case, I end up with +30. So this is a powerful way for students to demonstrate their understanding, or if students struggle with that understanding, that we can let them work through it, and then we can demonstrate after they're finished how you would do this with a visual representation. I found that the most effective way to teach number proofs is through the math workshop model. This is a 3-part model that starts with inspire, then inquire, then reflect. Inspire is the teacher-driven part of the lesson. This is where we get students excited about the activity. The first time we do this activity, we're also spending some time here explaining how the activity works. Then for part 2, that's the inquire section. So what we do is we give students a list of equations or inequalities, and then they just go and create their proofs. Whether you're doing this in a physical classroom or online, for the inquire section, we let students work in small groups, usually 3 or 4 is ideal, so they can sit at a table, or we can create a chat room, and students can have their discussions and complete their problem sets together. Then for part 3, reflect, there are a number of ways for them to reflect. My favorite is a share out. So we can bring the group back together. Each group shares 1 or 2 of their solutions. And this is also a great time for them to get peer feedback from the other groups, or you can also give feedback as the teacher if you find that there are any misconceptions at this point. So if you'd like to use number proofs with your students but want some more support and information, visit roomtodiscover.com/online. You'll find blog articles on number proofs themselves on the 3-part workshop model. You'll also find complete number proof lessons, including lesson plans, graphic organizers, problem sets, and rubrics. We also offer workshops and coaching. So if you really wanted to go in depth, you can take a full number proof workshop, or you can work with a one-on-one coach who will help you and your students get the most out of number proofs. So you'll find all of this, both free content and premium content, at roomtodiscover.com/online. Before you go, don't forget to like this video, subscribe to our channel, and if you have any feedback, leave it in the comments. See you soon.